All right, folks, welcome to the last video of the module and of the course. So you have just about seen my face for the last time, if you can help it. So we are going to wrap things up by talking about some secondary stuff about using regressions to make predictions. So by now you should be familiar with how to do that and how it conceptually works and how mechanically it's calculated. And if you're wondering where's the hypothesis test, there is such a thing as hypothesis testing for aspects of regression, but it's just not really important at an introductory level. So long story short, there's no hypothesis test in this course that we're going to associate with regression. We're just using it to make predictions. So let's talk a little bit about this idea of extrapolation. So extrapolation, and I have a little chart of it on the board, extrapolation is a really common mistake that gets made with prediction. So prediction in general is, flawed. There's always error in your predictions unless you have a perfect correlation, which never really happens. So there's always error there. Your estimates are always going to be, at least a little bit inaccurate on average. But extrapolation explodes those problems by estimating values outside of the range used for the actual measurements. We had an example of extrapolation at the end of the last video when we calculated the relationship between age and reading level, but used children between 3 and 7, and then we started plugging in old dudes like me and my dad. Those estimates are not likely to be accurate. In fact, they're likely to be very inaccurate. The farther outside the range of scores you're actually working with that your predictions go, the more nonsensical they can become. The most common mistake made with prediction is extrapolation in general, but it's most commonly used to project into the future. So as we see here, we've got a woman in a wedding gown, and she's being told, okay, you had 0 husbands yesterday. You have 1 husband today. Obviously, you are picking up husbands at the rate of 1 a day, so a few weeks from now, you're going to have 4 dozen husbands. You're going to be adding 1 every single day. Of course, that's absurd. And the reason why is it's extrapolating from 2 data points where a very meaningful change in the number of husbands has occurred. It was 0 yesterday, it's 1 today. Extrapolating beyond that is going to lead to some absurd conclusions. For example, it'd be like saying, okay, I had $20 in my pocket yesterday and I have $40 today, so obviously I'm going to keep doubling my money every day for the rest of my life, or I'm going to keep adding $20 every day for the rest of my life. Both are a form of extrapolation, and it's going to lead to some really absurd results. So projecting into the future is the single most common way that extrapolation goes awry. Projecting into the future is always kind of tricky because you are always estimating outside the range you've actually used, because again, it's stuff that hasn't happened yet. So what do we do in that case? Well, we're very cautious about making predictions about the future, and we try to predict specific things happening in the near future. Those predictions tend to be more accurate than, say, trying to estimate what the world's going to look like in 1,000 years. That's based on current trends. That's absurd. So extrapolation is a common mistake that we make with this stuff, and the rule of thumb is just stick to predicting values that are inside the data set you started with. If you have to go outside of that, like when you're predicting the future, stick to things that are very easily, narrowly defined and are in the near future, and extrapolation will be less of a problem. All right, a little bit more. Again, we've talked about the idea of simple linear regression being simple. It involves just individual predictors and individual criterion variables. So you have 1x and 1y. You use the 1x to estimate the 1y. But in reality, the whole point of prediction is to be as accurate as possible. Sometimes you can say, okay, what if I plugged in multiple predictors? I'd get a more accurate prediction, I think, than if I just used 1. And that oftentimes really is the case. So we can create what's called multiple regression, where we plug in multiple predictors. And the formula looks a little intimidating, but it's, again, pretty easy for computers to deal with. But basically what you see here is you have multiple different x's, multiple different predictor variables, and k just means as many as you've got, so however many you're using. Each one has its own slope, and we have a combined y-intercept. We have just one y-intercept for the whole thing. So each predictor has its own slope. You multiply the slope of that specific variable by the score on that variable. You add them all together, and then again you add the y-intercept. And the y-intercept would be the value of y when all the predictors are zeroed out, when all of them are at 0. So again, it's a little bit trickier to calculate by hand. It would take longer, but we're not doing that. For computers, it's pretty fast, and the logic, again, is just every single predictor has its own slope, and we multiply each predictor's score by its slope, add them all together, add the y-intercept, we get a predicted value for y. So we can plug in given values for each x. Let's say, again, we've talked about admissions officers before. Let's say you are running admissions at a school. You want to predict the GPA of a student, but you don't just want to use standardized test scores. You want, again, a more accurate prediction by plugging in things like their GPA in high school, which is another predictor of college GPA, and say the class year that they are currently in. For example, data from a junior might not be as accurate as data from a senior because the senior is closer to where they're going to be when they enter college. So those are different forms of multiple regression. You also can use what's called multivariate regression, where we use multiple criterion variables. There are multiple outcomes, multiple y factors. You could technically do that with one predictor, but that's not really going to be very common. Usually in a multivariate regression, you have multiple predictors, multiple x's, being used to predict multiple outcomes. So say you wanted to predict not just the predicted GPA for a student, but also their reported satisfaction with college and also their likelihood to graduate within 4 years, something like that. Those are all different outcomes, different criterion variables. Multivariate regression could help us estimate that. So that's the extent to which we're going to talk about this stuff here. But it's kind of a preview for a lot of graduate level stats. Like I said, if you go to a graduate program that has statistics in it, you're going to be working with a lot of regression models, a lot of prediction models overall. Very, very, very common framework for more advanced questions. All right, so let's wrap things up. Correlations let us make those predictions, but of course, we have to do some extra calculations, even if we already have the correlation, to get to that point. But it's not very difficult to do. You just have to remember those handful of calculations you need to make. Regression is a large family of techniques for higher level analysis that usually revolve around trying to predict things that haven't happened yet or that are unknown. The regression line is the simplest form of regression. It lets us predict scores on a criterion variable based on scores on a predictor variable. And again, it all ties into this linear regression equation. Now, one thing to note, the book has some extra detail on regression. We're trying to keep things straightforward as we wrap things up. You're only going to be responsible and you're only going to be tested on the material in the lectures. So that kind of puts a pin on things. Next up, there we have practice quizzes. We have your 5th graded quiz, which you'll want to turn in, any homework that you haven't completed, and get ready for the final. You know there's going to be stuff on correlation and prediction on the final. There's no way I'm going to just mention it and not test you on it. You know you're going to be choosing hypothesis tests, including perhaps a correlation, including I might ask you a situation about just predicting scores and expect you to recognize that it would involve a regression. So you'll be choosing what procedure is appropriate. You'll also be running hypothesis tests. You might very well be calculating a correlation and turning it into a regression line. You might be calculating probability. There might be bigger questions on method. Everything is eligible on this final exam, but you have a pretty good sense of, or you should have a good sense of what the big major topics are. So again, do everything you can to prepare for that final. Contact me if you have any questions, and best of luck to you. Thanks for sticking this course out and seeing things through, and hopefully you'll come out of it with a result that you are happy with. All right. It's been a pleasure recording these videos and the talking to you individually that I've done with some of you, and I hope it's been a relatively positive experience, or at least as painless as possible for y'all. All right, have a good final, and best of luck with the remainder of the summer session and with your upcoming courses.